Hello students, this video is continuation to the previous video of chain rule. Here we have discussed the two different chain rule case. So in the last video, we have discussed the chain rule like the first chain rule when we have a composition of the function. We are saying that if z is a function of single variable say u and u is a function of two variables, so more than one variable say x and y, then the derivative of z with respect to x. So according to the derivative of chain rule, firstly z depend upon u only. So because z depend upon a single variable, so its formula is f dash u. But u depend upon x and y, and we want to differentiate it with respect to x, so we can write it as curly g upon curly x. Similarly, if we want to differentiate z with respect to y, then this is f dash u into, we can say the u differentiate with respect to y and u is g. So I can write it as curly u upon curly y or curly g upon curly y, right? So basically here we use the chain rule concept that if z is the function of single variable u and u is the function of x and y, then if we differentiate z with respect to x, then we need to follow the chain that we firstly differentiate with respect to u and then u with respect to x. And if we want to differentiate z with respect to y, then we need to follow the chain. Firstly, we differentiate z with respect to u, and then we differentiate u with respect to y. Basically, it is a concept of the derivative composition of the function, because in this case, I can write it as z because u is nothing but a function of x and y, right? So in that case, if I want to differentiate z with respect to x, so firstly, I'm going to differentiate f with respect to this whole function, right? So I can write it as d by d of g of xy of the function f of g of xy, right? And then we differentiate g of xy because it depends upon more than one variable, so we can differentiate it with respect to x. Okay, so for example, so we have discussed like u is a function of say sine of x square plus y square. So we can consider x square plus y square is a function of x and y, and we consider it as u only. So if I differentiate z with respect to say x, so u with respect to x, or we can say, then we can write uh, curly u upon curly x. This is equal to, firstly we differentiate sine. Derivative of sine is cos of x square plus y square, and then we differentiate x square plus y square with respect to x. So in that case, we can get the answer as 2x times cos of x square plus y square. So this is the concept which we have discussed in our last uh, video also. So now in the second uh, chain rule, we have discussed that this is the reverse of this above property, that if z is a function of say more than one variable, that is a function of say x and y, but x and y they are further function of single variable t. Say x is a function of t, x is a function of t, and y is again function of t only. So in that case, because if I replace the value of x and y here, so basically z depend upon single variable t only. So we can differentiate z with respect to t as a derivative, total derivative, right? So in that case, what is the derivative here? Now in this case again we follow this chain that z depend upon more than one variable x and y, but because these two variables depend upon single variable t, so if I differentiate z with respect to t, so in this case we need to follow the chain that firstly we differentiate with respect to x, then with respect to t, and with respect to y, and then with respect to t. So it is curly f upon curly x into dx upon dt, because z depend upon two variables, so we use partial derivative, but x depend upon single variable, so we use derivative, right? But z also depend upon y, so curly f upon curly y, and y again depend upon single variable t only, so it is dy upon dt. So these are the two properties which we have already discussed in our last video. So now we come to the third case. The third case is chain rule number 3 is if z is a function of x and y, and x and y they are further function of say u and v, it depend upon more than one variable, then in that case, so even if I replace the value of x here as a function of u and v, y as a function of u and v, so it means that z is basically depend upon two variable u and v. So what is the derivative of z with respect to u? So in this case, it is a partial derivative of z with respect to u. So in this case, it will follow chain that z depend upon two variable x and y, but x and y they further depend upon u and v, right? So how do we differentiate z with respect to u? So in this case, it will follow a chain z depend upon x, x also depend upon u, z depend upon y depend upon u. Okay. So what is the derivative of z with respect to u? It is curly f upon curly x into curly x upon curly u and curly f upon curly y into curly y upon curly u, because z depend upon two variable and these two both the variable depend upon u. So firstly I differentiate with respect to x, then x with respect to u, then with respect to y with respect to u. Okay, it may be possible that z depend upon more than two variable. So if z depend upon say other variable w also, then and w also depend upon u and v, then we are also going to add one more term here, right? Similarly, if we want to differentiate z with respect to v, so in that case again we'll follow the chain that z depend upon x, x depend upon v, z depend upon y, and y depend upon v, right? So it will gives us curly z upon curly v as it is equal to curly f upon curly x upon curly v plus curly f upon curly y into curly y upon curly v. So this is the chain rule which we are going to follow here. So like it may be possible that in some problems we will use more than one chain rule. That is, in most of the problem we'll find out that we are going to use the first and the third identity, right? The second one is completely different case. Okay. So to understand the above chain rule, now we are going to implement this rule to some problems. Let's start with first problem. So the first question is, we are given that z is equal to log of u square plus v, where u and v they further depend upon x and y. And we want to find out the value of this expression 2y curly z upon curly x minus curly z upon curly y. So basically we find out here that z is the function of u and v, where u and v both depend upon variable x and y, right? So we want to find out curly z upon curly x. So what is curly z upon curly x? So according to the chain rule, z depend upon u, z depend upon u, and u depend upon x. Z also depend upon v also depend upon x. So we are going to use this chain rule, curly z upon curly u upon curly x plus curly z upon curly v into curly v upon curly x. Similarly, curly z upon curly y, this is curly z upon curly u upon curly y, curly z upon curly v, and curly v upon curly y. So basically, we need these derivatives if we want to calculate the value of curly z upon curly x and curly z upon curly y. So let us firstly start with the derivative of z with respect to u and v. So what is z here? Z is log of u square plus v. Now here, what we find out here that z depend upon single variable and this single variable depend upon two variable, because in this case your function is logarithmic. So basically here we are going to use the very first chain rule that z depend upon single variable and this single variable depend upon two variable. Okay, so here we are going to first use the first chain rule. So the derivative of z with respect to u, So how do we calculate this? This is curly z upon curly u. So firstly, we differentiate log. So what is the derivative of logarithmic function? We know that the derivative of log of x is equal to 1 upon x. So basically, it is a composition of the function. Firstly, we differentiate log. Derivative log is reciprocal of the variable. So it is 1 upon u square plus v. And then we are going to differentiate it with respect to u. So curly by curly u of u square plus v. So this comes out to be 1 upon u square plus v. And because it is a partial derivative, so when we differentiate with respect to u, it means we are treating v as a constant. So another formula we are using here, the derivative of polynomial x power n is n times x power n minus 1, and derivative of constant is 0. So here derivative of u square 2u and derivative of v is 0. So the value of curly z upon curly u is 2u upon u square plus v. This is the value of curly z upon curly u. Now we are going to calculate curly z upon curly v. So now again we are going to differentiate z with respect to v, means firstly we need to differentiate logarithmic function. Again derivative of log is reciprocal of the variable, that is 1 upon u square plus v. But now we are going to differentiate u square plus v with respect to v. And again, derivative with respect to v means we are treating u as a constant. So derivative of u square is 0 and derivative of v is 1. So it is 1 upon u square plus v time, this is 0 plus 1. So its value comes out to be 1 upon u square plus v. So what is the derivative of z with respect to v? This is 1 upon u square plus v. So these two derivatives are known. Apart from this, we need the derivative of u with respect to x and y. So what is given here? That it is given here that u equal to, wait a moment, let me delete this part. Right. So what we need to calculate, u is equal to e raised to the power x plus y square. So u equal to e raised to the power x plus y square, and v is equal to x plus y square. V is equal to x plus y square. So again, we need to calculate curly u upon curly x. Again, we find that it is a composition of the function. So composition of the function means firstly we need to differentiate exponential function. So what is the derivative of e power x? It is e power x only. So derivative of e power x plus y square is e power x plus y square into curly by curly x of x plus y square. So when we differentiate with respect to x, then y is treated as constant. So its derivative is e power x plus y square into 1 plus 0. So it is e power x plus y square. So this is the value of curly u upon curly x, e power x plus y square. Next is derivative of u with respect to y. So again, curly by curly y of e power x plus y square. So again, it is a composition of the function. Firstly, derivative of exponential function is exponential, and then derivative of x plus y square with respect to y. So when we differentiate with respect to y, then x is treated as a constant. So the derivative of x with respect to y is 0, and derivative of y square is 2y. Like I told you, derivative of power function is n times x power n minus 1, and derivative of constant is 0. So with this, we can get the value of curly u upon curly y is equal to 2y times e raised to the power x plus y square. Next, we need to find out the derivative of v with respect to x. So if we differentiate curly v upon curly x, this is curly by curly x of x plus y square. So we are differentiating with respect to x, then y is treated as constant. Its derivative is 1. So curly v upon curly x is 1. And if we differentiate v with respect to y, then this is curly by curly y of x plus y square. Derivative of x with respect to y is 0. Derivative of y square is 2y. So it will gives us the value of curly v upon curly y as 2y. So basically we get the value of all the required derivative. So on the basis of that, we can get the value of curly z upon curly x. So according to this chain rule, what is the value of curly z upon curly x? Curly z upon curly u, it is 2u upon u square plus v time curly u upon curly x. Curly, it is e power x plus y square. It is e power into e power x plus y square plus, and then curly z upon curly v. Curly z upon curly v is 1 upon u square plus v, 1 upon u square plus v, and derivative of v with respect to x, this value comes out to be 1 only. So it is 1. Okay, and what about, so if we combine them, let me clear this particular part. So if we clear this part, so we can say that its value comes out to be 2u into e power x plus y square plus 1 upon u square plus v, which is again u, right? And if we calculate curly z upon curly y, it is curly z upon curly u, it is 2u upon u square plus v, and curly u upon curly y. Curly u upon curly y, it is 2y time e raised to the power x. 2y time e raised to the power x plus y square. And curly z upon curly v is 1 upon u square plus v into derivative of v with respect to y is 2y. It is equal to 2y. So in this case, let me clear this whole part here. Right. So in this case, so if I solve this particular part, so we can get u square plus v is the LCM. So it is 2y is common. It is 2u e raised to the power x plus y square plus 1. So if you just see here that the entire expression is similar to this one, 2u e raised to power x plus y square plus 1 upon u square plus v. The only additional term is 2y. So this is the value of curly z upon curly y. Okay, so what is curly z upon curly y? This is equal to 2y time curly z upon curly x. This is what we can conclude from this particular expression, right? And if we take this term on the other side, so we can get here that 2y curly z upon curly x minus curly z upon curly y is equal to 0. So it means that the value of this particular expression is 0, right? Okay, so because we have, in this case, we'll get 2y is common, and the rest part is nothing but equal to curly z upon curly x only. So it means that curly z upon curly y is equal to 2y times curly z upon curly x. And hence we can get the solution of this problem, right? So here we have used the chain rule, case number 1 and case number 3. Okay, now let us come to the next problem. Okay, so if we just look at this problem here, we find that w is the function of x, y, z, but x, y, z, they are function of u and v. That means w depend upon three variable x, y, and z, but x, y, z, they depend upon two variable u and v. So it means that w also depend upon u, w also depend upon v, but it follow a chain rule. Z with respect to x, with respect to u, with respect to y, with respect to u, with respect to z, with respect to u. Similarly, in term of v. And again, we need curly w upon curly u and curly w upon curly v also. So firstly, if we use the chain rule, then what is the formula of curly w by curly u? So curly w by curly u, this is equal to curly w by curly x upon curly u, curly w by curly y upon curly u, curly w by curly z by curly u. And similarly, if we write curly w by curly v, then this is curly w by curly x by curly v, curly w by curly y by curly v, curly w by curly z by curly v. So it means basically we need firstly the two derivative of w with respect to xyz and derivative of xyz with respect to u and v. So firstly, let us calculate the derivative of w with respect to x. So what is the derivative of w with respect to x? So again, you can see here it is a composition of the function. The first function is the power function, right? It is like f of x y z raised to power n. So we use here the power rule. The derivative of x power n is n time x power n minus 1. So firstly we use the power rule. It is like curly by curly x of x square plus y square plus z square raised to the power 1 by 2. So firstly we use power rule 1 by 2 times x square plus y square plus z square raised to the power 1 by 2 minus 1 into derivative of this function with respect to x. Curly by curly x of x square plus y square plus z square. So this is equal to 1 upon 2 times square root of x square plus y square plus z square because the power is minus 1 by 2. Minus 1 by 2 means in the denominator we have a square root of this function. And if we differentiate with respect to x, again we are using power rule, then y and z are treated as constant. So derivative of x square is 2x, but derivative of y and z is 0. So its value comes out to be 2x upon 2 times square root of x square plus y square plus z square. So 2 and 2 get cancelled out. Okay, so from here we can get curly w by curly x as x upon square root of x square plus y square plus z square. Similarly, we can find out the derivative of w with respect to y and with respect to z. So what is the derivative of w with respect to y? This is equal to curly by curly y of x square plus y square plus z square raised to the power 1 by 2. So firstly we use power rule, power minus 1 by 2 into derivative of x square plus y square plus z square with respect to y. So it means that curly w by curly y, it comes out to be 1 upon 2 square root of x square plus y square plus z square into 2y. So 2 and 2 cancel out. So it is y upon square root of x square plus y square plus z square. And also this function is pairwise symmetric, means if we interchange x with y or x with z, your function is same. So it means that I can find out similarly curly w by curly z as z upon square root of x square plus y square plus z square. Right? So this is the derivative of w with respect to x, with respect to y, and with respect to x. Okay. So because this function is pairwise symmetric, means if I interchange any two variable, again your function will remain same. So if one of the derivative is known, we can find out the other derivative by simply interchanging the variables. Okay. Next thing is we need the derivative of x, y, and z with respect to uv. So we are given that let us calculate curly x upon curly u. This is curly by curly u of x is u cos v. So it is u cos v. If we differentiate with respect to u, then v is constant. Its value is cos v. And derivative of x with respect to v, it is curly by curly v of u cos v. And if we differentiate with respect to v, then u is constant. Derivative causes minus sign. So it is u times minus of u times sine v. And derivative of y with respect to u, this is curly by curly u of y is given as u sine v. So u sine v, its derivative is sine v. And if we differentiate y with respect to v, then this is curly by curly v of u sine v. Then in this case, u is constant, derivative sine v is cos v. And now if we differentiate z with respect to u, z is given as u into v. So derivative of z with respect to u, this is v, and derivative of z with respect to v is u. Sorry. So all the six derivatives are known to us. Six derivatives this and three, nine derivatives are known. So now we substitute all this value here. So if we substitute their value here, then we can get curly w by curly x. This is basically equal to, this is x upon square root of x square plus y square plus z square. Curly x upon curly u is cos v, and this is y upon square root of x square plus y square plus z square, and derivative y with respect to u is sine v, and curly w by curly z, which is z upon square root of x square plus y square plus z square, and derivative of z with respect to u is v. Okay, and if we calculate here curly w by curly x, which is again x upon square root of x square plus y square plus z square, but derivative of x with respect to v is minus u sine v, and this is y upon square root of x square plus y square plus z square. Derivative y with respect to v is u cos v, and this is z upon square root of x square plus y square plus z square, and derivative of z with respect to v is u. So now say this is number 1 and this is number 2, right? So now what we need to do, we multiply curly w by curly u with u, and this is with v, and subtracting. Then what do we get? Okay, so if we multiply, let us consider some different color. Okay, so I'm writing u curly w by curly u minus v curly w by curly v. So this is equal to, okay, I think we need a bigger space here. So this is equal to, uh, if I multiply it with u, then this is u cos v, this is minus uv sine v. Okay, so this is whole x square plus y square plus z square is the LCM. It is to the power 1 by 2. This is the LCM. So u cos v, u cos v minus uv sine v into x multiplied by x. And here u sine v plus uv cos v. Let me clear this particular part so we'll get more space here. Okay, plus y is there. Here we have a u sine v, u sine v minus uv cos v. Okay, and here it is time y plus z time uv minus uv. So here z coefficient is cancelled out. It means that here we left with the term of u and coefficient of x and y only. But if we just look at the answer, in the answer we are having u and v only. So firstly, we need to know that what is x square plus y square plus z square. Okay, if we take so that we can find out because we need to replace here x, y with the u and v only. So if we just solve this particular expression, so this is u cos v. I simply take the numerator term. Your numerator is u cos v, u cos v minus uv sin v into x. X is again u cos v, u cos v plus, that means if I open this particular bracket, I'm considering first term here, this particular one, right? So u cos v minus u v sin v into x. X is u cos v. So if I'm replacing here the value, so this is equal to u cos v into u cos v. This is u square time cos square v minus u square v sin v into cos v. Okay. And if we consider here the second term, this is the first part. Now the second term is u sin v minus uv cos v, and we multiply it with y. So what is y? It is u sin v. So basically this is equal to u square sin square v minus uv square, sorry, u square v, u square v cos v into sin v. Okay, right. So if we adding these two terms, u square sin square v, and this is uv cos v sin v. It is u square v sin v cos v. Okay, so if we adding these two terms, so we can get u square common, sin square v plus cos square is 1. And in the denominator, if we take the sum of x square plus y square plus z square, so if we write x square plus y square plus z square, this is u square cos square v plus u square sin square v plus u square v square. So this is u square into cos square v plus sin square v plus u square v square. So it is u square common 1 plus v square. Okay. So if I take the square root of this whole term, let me add one more slide here. If I take the square root, so what do we get? U curly z upon curly u minus v curly z upon curly v. This is equal to u square cos square v plus u square sin square v, u square sin square v. Okay, so here we already have a negative sign. So basically this sign is positive and this sign is negative. So here we have a positive sign and here we have a negative sign. So this term and this term get cancelled out. So we left with only u square cos square v plus u square sin square v in the numerator, and in the denominator we have a square root of u square into 1 plus v square. So this is in the numerator it is u square u into square root of 1 plus v square. So 1 u get cancel out. So its value comes out to be u times square root of 1 plus v square. So this is the value of u curly z upon curly u minus v times curly z upon curly v. So this is the solution of this problem, right? So in this case, basically we need the line partial order derivative w with respect to x, with respect to y, with respect to z, then x with respect to u, with respect to v, y with respect to u, and with respect to v, and z with respect to u and v. And then substituting to get the value of curly w by curly u and curly w by curly v. Then we need to multiply the first term with u and the second term with v and subtracting. So because when we multiplied with u, here I multiplied this whole expression with u and I multiply this whole expression with v. And when we subtracting, so it is u into cos v. This is there, and this is minus uv sin v. And because we are subtracting here, so it means that this negative and negative become positive. So it is uv sin v time x. And here I multiplied with u, so it is u sin v. This is the first term and minus uv cos v. So it is minus uv cos v time y. And I multiplied with u, so uv. When subtracting, they cancel out. So basically, we left with two terms. And because in the answer we need u and v only, so I simply replace the value of x with u cos v. So u cos v is already there. When I multiply it with x is again u cos v. Because what is x here? X is again equal to u cos v. So u cos v into u cos v is u square times cos square v and uv sin v into u. So u into u is u square v times sin v cos v. We'll get u square v sin v cos v. This is the first term. And now we consider the second term. This is u sin v minus uv cos v times y. And what is y? Y is u sin v. So if I replace here y with u sin v, then u sin v into u sin v is u square times sin square v. And here again, uv into u, it is u square v cos v into sin v. And when we are going to add them, so when we are going to add them, because for these two terms, then we find that these two terms get cancelled out. So we left with u square cos square v and u square sin square v. This is about the numerator. And in the denominator, we need x square plus y square plus z square square root. So when we adding, squaring and adding, x square is u square cos square v, y square is u square sin square v and z square is u square v square. So cos square v plus sin square v is 1. So we left with u square and u square v square. So it will gives us. So here we have added u square plus u square v square. So u square again common, it is u square into 1 plus v square. This is the value of x square, y square, z square. But in the denominator, we have a square root of this whole term. So square root of this term is square root of x square plus y square plus z square is equal to square root of u square into 1 plus v square. So this is u times square root of 1 plus v square. So numerator term, we get it as u square cos square v plus u square sin square v, and in the denominator we have this term. So one power of u get cancelled out. So this is the required answer which we need in this question. Okay, it is a bit complicated, but here we have used the again first and third identity, first and third case of chain rule. Okay, now let us move to the another problem. This is again very important problem. So if you just look at problem here, we are given that u is a function of x, y, z, and we need the derivative of u with respect to x, with respect to y, and with respect to z. So basically, if you just look at here, u depend upon three variables, where each of this variable depend upon two variables. So what can I do? I start with let We simply name it as let A equal to x minus y, B is equal to y minus z, and C is equal to z minus x. So what is U? U is basically a function of A, B, and C, where A, B, C, so we simply convert it into a problem where U depend upon three variables, and these three variables further depend upon x, y, z. Although it depend upon two variable only, so I can assume I can differentiate it with respect to third variable also, right? So it means if I want to differentiate with respect to x, then we are going to follow the chain. Similarly for y and z, right? So what is the derivative of u with respect to x? This is curly f upon curly a into curly a upon curly x, curly f upon curly b into curly b upon curly x, curly f upon curly c into curly c upon curly x. Now, because your function f is unknown in this case, so it means that curly f upon curly a remain unchanged, so it remain curly f upon curly a only. But what is the derivative of a with respect to x? So a with respect to x means we differentiate x minus y with respect to x. So derivative of x with respect to x is 1, with respect to y is 0, so its value is 1. And again, no change in curly f upon curly b because your function f is unknown. And if we differentiate b with respect to x, what is the derivative of b with respect to x? Because it depends upon y and z only. So it means that its derivative is 0. And if we differentiate f with respect to c, no change. But the derivative of c with respect to x, that means curly by curly x of z minus x. So its derivative is minus 1 because if I differentiate with respect to x, then z is treated as constant. So its derivative is minus 1. So its value comes out to be curly f upon curly a minus curly f upon curly c. This is the value of curly u upon curly x. Now similarly, we are going to calculate the derivative of f with respect, u with respect to y and with respect to z. So what is the derivative of u with respect to y? Again, following the chain that u is a function of x, y, z, a, b, c. So we are going to differentiate f with respect to a and then a with respect to y, f with respect to b, b with respect to y, f with respect to c, c with respect to y. So we are given here that a is equal to x minus y, b is equal to y minus z, c is equal to z minus x. So curly f upon curly a remain unchanged. What is the derivative of a with respect to y? This is minus 1 because derivative of x is 0, derivative of y is 1, so its value is minus 1. And again, curly f upon curly b remain as it is. Derivative of b with respect to y, this is 1 minus 0 because derivative of y with respect to y is 1, but z is 0 with respect to y. Okay, because that is treated as constant. And if we differentiate c with respect to y, c doesn't depend upon y. So automatically the derivative of c with respect to y is 0. So it means that its value comes out to minus curly f upon curly a plus curly f upon curly b. This is the derivative of u with respect to y. And last is the derivative of u with respect to z. So this is equal to curly f upon curly a upon curly z, curly f upon curly b upon curly z, plus curly f upon curly c upon curly z. Okay, because f depend upon abc and abc depend upon xyz. So what is the derivative of a with respect to z? The derivative of a with respect to z is 0 because a depend upon x and y only, right? And what is the derivative of b with respect to z? This is 0 minus 1, that is minus 1. And what is the derivative of c with respect to z? This is 1 minus 0, that is 1. So if we substitute its value here, curly f upon curly a into 0, curly f upon curly b into minus 1, curly f upon curly c into 1. So it will give us curly u upon curly z equal to minus of curly f upon curly b plus curly f upon curly c. So all the three derivatives are known, and what we need their sum. So let us add all these derivatives. So curly u upon curly x plus curly u upon curly y plus curly u upon curly z. What is curly u upon curly x? It is with respect to a minus with respect to c. So curly f upon curly a minus curly f upon curly c plus the derivative of u with respect to y. This is minus of curly f upon curly a plus curly f upon curly b. And last is the derivative of u with respect to z. This is minus of curly f upon curly b plus curly f upon curly c. Now you can see here there's a derivative of a, and a cancel out, c with c cancel out, b with b cancel out because all the derivatives with opposite sign. So it means that the value of this derivative comes out to be 0. Hence the result. Okay. So here in this particular video, we have discussed some the problems based on the third property of the chain rule, because in the previous video we have already discussed the first two cases. So here we have discussed the case number 3, when your function depend upon more than one variable and these variables further depend upon more than one. So this is how we can implement the chain rule in the different problems we have discussed in this particular part. Okay, so just try some problem. Still, if you find out any doubt or any query, you can post your query. I'll try to provide you the solution of this. Right. Thank you all of you. Have a nice day.